In this video, we're going to discuss coordinate systems and transformations, and we're going to do it at a fairly superficial level. So we're going to ignore the corrections that are made to take information that's on an ellipsoid, so the Earth, and present that as a planar surface, so a flat surface. So we're ignoring those corrections. They are in there. If you work in with one projection system and switch over to another, there's corrections made to account for that location on an ellipsoid or sphere. So we're going to speak in terms as though we're just dealing with that planar surface. And before we get into individual coordinate systems, we'll just kind of speak to what we mean here. So in this little example, we can see that point has an easting and a northing of 0, 0, and an elevation of 0. So that's my origin. Now, if I tell you that we have an object at coordinate 200, 200, well, that probably doesn't have a lot of value without telling you where that's related to. So if I say I have a object in my backyard at coordinate 200, 200, well, we can also tell you that we're talking about the direction, so northing and easting, and the origin is based off of the corner of my house. So we can say, well, let's go north 200 meters from the corner of my house, and then go east 200 meters from that point, and that puts you at our known location. So that's kind of a really simple example, and it's common to use local coordinates on jobs where you set up your survey control and you're only working with information relative to those points. Now, it's also very common to work with well-defined coordinate systems where if I tell you that I'm at a certain coordinate, we know exactly where that is. But that certain coordinate may vary. Well, your location on the Earth will depend on what coordinate system you're using. So I'm just going to delete that. I'm going to turn off my labels here. So if I go over here, I've got a georeferenced ortho image that's using the New Zealand National Coordinate System. And we can see that location in space, and as I'm hovering I can see my points, my coordinates here. So first number starts with a 2, or if as I zoom out, I've got the same image, but it's using another coordinate system. So here my easting starts with a 6. So if I were to bring in my survey data, I'm going to open a new file for this. I'm going to leave my coordinate system as undefined. And there we are. So these points, the lengths make sense, their location relative to one another makes sense. But if I try to relate that to somewhere in the world, we need a coordinate system to be defined to relate that to somewhere in the world. So if I come up here, I can say that that's using that New Zealand coordinate system. And now that I've got that defined, I can see exactly where I'm at in the world. So, back in this example that we started with, we'll bring that file in. And here, even if I leave that undefined, since that's the coordinate system that it was surveyed in, and that's the coordinate system this data's in, we're great. If I want to switch that information from being in that New Zealand coordinate system to another coordinate system, I can do that on import, or I can do it after the fact. So I'll do it after the fact here. So I've got those features that I'd like to switch selected. I'm going to click Feature Tools, Transform, and I want to go from that coordinate system to, and that other data is in UTM zone 60 south. We'll hit OK. We'll hit Apply Transfer. That information is no longer here. But if I go over here, it's in the right location. So that was a transformation. Now, we don't have to do that after the fact. When we bring that information in, we can click Insert File, and I'll tell it I want to work in UTM zone 60 south, but I need to tell it what coordinate system coming from in order to change those numbers. So change that number that starts with a 2 to relate to that other coordinate system. And there we are. So instead of dealing with 2, we're dealing with a 6.